Okay, we're going to start the next unit, which involves perimeter area and volume with something called the Pythagorean Theorem. So you may or may not have heard of it before. Hopefully you have. I'll do a quick intro. Normally I would get you to make this, but if we start with some graph paper and we cut out some squares, cut out a 9 by 9 square, a 12 by 12 square, and a 15 by 15 square, right here. If we arrange the three squares so that two of their vertices are contacting the other two squares. So remember, the vertices are these little corners right here. So if we arrange them in that way, what shape do you see within? Well, you should see a right triangle. I sure hope. And there it is right there. So what's really fascinating here is that if you took the side lengths of each one of these, this is a 9 by 9, so this is a 9. This side here is a 15, and this side here is a 12. Okay, and no matter what you do with those three numbers, you cannot add them together. You can't add 9 and 12 together to get 15. Like, there's no relationship between the single digits. But what you can do is, if you look at the squares of the numbers, there is a relationship. Okay, so when you look at this one here, if you took the square, this is 9 squared, this is 81. This would be 12 squared, or 12 times 12, which would be 144 little squares. This one here is 15 squared, which is 225. Now, if you look at those three numbers, 81, 144, and 225, there is a connection between those. Because if you add those two smaller shapes together, okay, in terms of their area, they do equal the larger area. So you could actually pick up the green square and put it on top of the yellow square, and the remaining uncovered pieces would be the same number of squares as the red square. Okay, and this is something that we call the Pythagorean Theorem. It does not work with just the single side lengths, but it does work with the squares of the side lengths. And this is how it's right here. So the sum of the squares, or the areas, of each leg of a right triangle is equal to the square, or the area, of the hypotenuse. So let's just talk about a few of those things. This right triangle means 90 degrees. Okay, is involved. That means it's a right triangle. The hypotenuse is the longest side, and it's always across from the 90. That's really, really important. Okay, the other two sides of the triangle that connect to the 90 are called legs. You'll notice I'm not using A, B's, and C's like you may have learned before. The one thing you really, really have to know, though, is that the hypotenuse must be the longest side. It can never be shorter than a leg. So when you do your calculations, that's going to be one of our checks. So this is the way I like to present this formula. I call it leg squared plus leg squared equals hypotenuse squared. Some people will have seen it as a squared plus b squared equals c squared, which is great as long as the a and the b are both legs. Okay, if they're not legs, then you can get messed up and you start adding, subtracting things incorrectly. So I'm going to show this as leg squared plus leg squared equals hypotenuse squared. The legs are attached to the 90 degrees, and again, this only works for 90-degree triangles. So we have some demonstrations here in Geometry Sketchpad we can look at. See if we can get them to fall within. So there's one, and if I grab this point A, I can move it and stretch it, and you'll notice all of the areas balance up here in the calculations. So that's one opportunity. You can just stretch that around and see that it still fits. We don't need to save that. And then the second one, and this one's a little more fun to do. Assuming it opened. Come on, open up. Of course it wouldn't, just to be a pain in the butt. So we'll close that and try this again. There we are. There's what I'm looking for. Okay, so now this one is a fun one. Let me just get my window a little smaller here. I'll move this up at the very least. Put that in the recording area. Okay, so now this one is drag the 5 polygon pieces. So you can see that I have a purple area and this blue kind of light blue colored, those represent the areas of the legs. So now if those areas of the legs fit within inside the area of the hypotenuse, we've proven our point. So we can take these pieces and we can drag them up, put them in the correct locations, and you should be able to see that the area of these two combined pieces make the area of that hypotenuse. Okay? Alright, so let's actually put it into action. And again, I like to write this in a certain way, so that's the way I'm going to do it. I'm going to say leg squared plus leg squared equals hypotenuse squared. So when I look at this triangle, I want to identify my legs. This is a leg, this is a leg, this is a hypotenuse. And this is an important point because I want to be able to make sure I put the information in the right location. And if I don't, I'm going to get some weird answers. So if I put this in here, I'm going to have 6 squared plus 8 squared equals hypotenuse squared. Okay, so this is 36 plus 64 equals h squared, so this becomes 100 equals h squared. Now we've done the 4 operations, add, subtract, multiply, divide, and all of their opposites. This is still an opposite operation, so the opposite of squaring a term is square rooting. So when we square root both sides, the h squared term just becomes an h because we have undone the squaring, and when we square root 100, we just get 10. So now I do a quick check. Is my hypotenuse longer than both of my legs? And it is, so this is a correct answer. Okay, our triangles can be written in strange ways. Let's just move this out of the way a little bit. Give ourselves a little more room to write. Again, I'm going to start with leg squared plus leg squared equals hypotenuse squared. So again, I would take a time and I would identify this is a leg, this is a leg, this is the hypotenuse. And if you're an a squared plus b squared equals c squared person, this is the kind of question that will get you, because the a is not a leg, you'll end up with an incorrect value. Okay, so this would be 21 squared plus 28 squared equals h squared. And on the left hand side, we could just let our calculator do most of that heavy lifting. So that entire left side simplifies to 1225, and all of that equals h squared. If I undo the squared term by square rooting, I get the square root of that is just 35. So again, I do a quick check. Is my hypotenuse bigger than both the legs? Yes, it is. Okay, so let's do one here with decimals. Does not matter that there are decimals. Okay, I'm just going to move that over. I'm going to do the exact same approach. Okay, leg squared plus leg squared equals hypotenuse squared. Now I'm going to stop here and take a good look at what's a leg. Well, this is a leg, this is a leg, this is a hypotenuse. So when I set this up, I don't want to just put the unknown on the right hand side. I have to put these things in the correct locations. So this becomes y squared plus 8.7 squared equals 12.5 squared. Now that's the correct setup. Okay, and again, this is the reason why I ask you to try the leg squared plus leg squared equals hypotenuse squared. You won't get caught making silly mistakes. And again, we let our calculator do a lot of the heavy lifting. Okay, so this is y squared plus 75.69. Come on, give me the 6, there it is. Equals 12.5 squared, which is 156.25. And because we're strong in our algebra skills, we know we can subtract 75.69 from both sides. Okay, and those would cancel. And I'd be left with y squared equals 156.25 minus 75.69. And I get 80.56. And again, how do I undo a squared term? I square root both sides, and I end up with y equals the square root of 80.56, which is 8.9 0.98 or approximately 9. That's pretty close. So if I put a 9 here, I do a quick check. Is 9 as a leg smaller than the hypotenuse? So yes, it is. So this is a good solution. Okay, now this one here, we have multi-steps going on here. Find the missing side length. We'll try to round to 2 decimal places. I'll be flexible on that for now. So if I looked at this triangle right here, I only have 2 pieces of information. I can't solve this problem. I need another piece of information, and the piece of information I need is right here. So what makes this is a 2-step problem is I have to solve the left triangle first, get the shared side between them, and then I can solve the right-hand side. Okay, so let's start with that left triangle. We'll do this one in purple. Here's my 90, so this is an H, or a hypotenuse. This is a leg. This is a leg. So when I set this up, leg squared plus leg squared equals hypotenuse squared, right? So I'm just going to leave it as L plus 12.5 squared equals 18.7 squared. I can also do that this way. Be very careful though, we have to make sure we do our exponents before we do any subtraction, so that is a correct statement the way it's written, just like that. Makes it a little easier for my calculator. 18.7 squared minus 12.5 squared equals, so I get an L squared value of 193.4. Let's try and follow the rules here. We'll take the square root of that, and I get 13.91 as my length. Okay, so if we do a quick check, 13.91, that's a leg. Is it smaller than the hypotenuse? Yes, it is. So that's a successful calculation. We move to the big triangle now. L squared plus L squared equals H squared. So in this case, the hypotenuse is the unknown. So I'm going to put in my 13.91 squared plus 26.6 squared equals y squared. So now I've got everything on the left-hand side nice and nicely arranged, so I can just square 13.91 plus 26.6 squared, hit equals. So the entire left side is 901.05 equals y squared. And again, to undo the squared term, I square root both sides, and I end up with a y value of 30.02 if we want to be particular. So this would be 30.02. Is that greater than this leg? It is. That's a good answer. Okay, so let's wrap things up. A couple of questions to try on page 445. Thanks for tuning in.